Let's have a look at this first question. The first question says, solve the one-dimensional biharmonic equation, which is this one. The fourth derivative of u with respect to x is equal to minus f, where in this case f of x is equal to 1, it's a constant function, and write down the general solution. So for the first question, we need to write the general solution of this ODE under the circumstances that f of x is a constant function. In the second problem, we have this function, single variable function, and we want to show that this is a solution to the boundary value problem. So we have the biharmonic, we need to show that this function satisfies the biharmonic equation and that it satisfies the boundary conditions u of 0 is 0 and u of 1 is 0. So these are homogeneous Dirichlet boundary conditions. And the derivative of the function at 0 equals the derivative of the function at 1 equals 0. These are homogeneous Neumann boundary conditions. So let's start to solve the first question. We have that fourth derivative of u with respect to x is minus 1. This can be written as u fourth derivative, right? When I use parentheses and 4 means derivative, not power of the function. So what I do is I integrate plus a constant that comes from integration. So u3 is minus x plus a. I integrate plus b. So now I have u second derivative is 1 over 2x squared plus a x plus b. Again, I have to integrate here. So now I have u first derivative is 1 over 2 times x cubed over 3 plus a times x squared over 2 plus b times x plus c. So this is u1 is x cubed over 6 plus a x squared over 2 plus bx plus c. Now I integrate From here I have that u of x is 1 over 6 times x to the power of 4 over 4 plus a over 2 times x to the power of 3 over 3 plus b times x squared over 2 plus c times x plus d. So now u of x is x to the power of 4 sorry, there is a minus that is missing. So here is a minus here, minus, minus. So here is a minus, here is a minus. So this is minus x to the power of 4 over 24 plus a x cubed over 6 plus b x squared over 2 plus c times x plus d. Sorry. Plus d. So now what I have done is that I have found the general solution. I have found the general solution where a, b, c, and d are real arbitrary coefficients, and in order to find if I have the in order to find a, b, c, and d, I need boundary conditions. So I need 4 boundary conditions here in order to define a, b, c, and d, because this is a biharmonic equation. So my general solution, I repeat, is minus x to the power of 4 over 24 plus a times x to the power of 3 over 6 plus b times x squared over 2 plus c times x plus d. Now let's go to my second question. Let's go to the second one. My function is u of x 1 over 24 times minus 4x cubed. Sorry, not this. I apologize for that. So this is minus x to the power of 4 plus 2x cubed minus x squared. This is my function. Now I need to check that this satisfies the biharmonic equation, so I will take the first derivative. So this is 1 over 24 minus 4x cubed plus 6x squared minus 2x. The second derivative is 1 over 24 times minus 12x squared plus 12x minus 2. The third derivative is 1 over 24 times minus 24 times x plus 12, and the fourth derivative is 1 over 24 times minus 24. This is minus 1, so I have the fourth derivative of u with respect to x is minus 1. So my function satisfies the biharmonic equation Now let's check the boundary conditions for u of 0 is u of 0 is equal to 0, u of 1, if I substitute, is equal to 0, so u of 0 equals u of 1 equal to 0. The homogeneous boundary conditions are satisfied. Now let's take, so the u prime of x is 1 over 24 minus 4x cubed plus 6x squared minus 2x. So for x equal to 0, this gives me 0. And for x equal to 1, this gives me 0. So from here, u prime of 0 equals u prime of 1 equals 0. So my homogeneous Neumann boundary conditions are satisfied. We can have a quick look. So in the first question, we have solved the one-dimensional biharmonic equation by simply integrating and incorporating these arbitrary constants. So my general solution is of this form, enclosed in this rectangular box. And for the I need only the general solution here. And for the second question, I take my function u, which is given. I compute up to the fourth derivative of the function, and I see that the fourth derivative is equal to -1, so the equation is satisfied. Then I check my boundary conditions. Homogeneous boundary conditions are satisfied. Then, since I have already computed the first derivative of the function, I substitute for x equal to 0 and x equal to 1. I see that these are equal to 0, so I have homogeneous Neumann conditions, and also these conditions are satisfied. So what I deduce is that u is a solution to my boundary value problem. Thank you again for paying attention to this video. I know it's it's a difficult problem, but I hope that you will find it as enjoyable as I have found it so far.